Hey, here's the second video on section 6.5, solving quadratic equations. And basically we're doing the last three problems, which involve some word problems. Now, historically, students find that word problems are a pain. They really shouldn't be, but a lot of people hate them. I would not get too concerned about these word problems. They're not a majority of the tests or quizzes that you take in Algebra 2. But so you can still get an A in the course without successfully doing a word problem. But I think you can do the word problems. They're not that intense. Okay, so this problem here is probably a difficult problem because there's a lot of steps to doing the problem. So let's try to read through these words and see if we can figure this out. We have two cars that leave an intersection, one traveling west and the other south. Okay, so there's a fast car and a slow car. And it doesn't matter which direction. Here's the center of the intersection. We'll make the slow car go west, okay? And we'll make the fast car go down south. And obviously the fast car would go a greater distance. After some time, the slower car is 7 miles nearer to the intersection than the fast car. Oh, okay, that makes sense. It's 7 miles nearer than the fast car. Now, how do we represent that? Let's consider x to be the distance of the slow car, okay? In a certain amount of time, this car is going west, and I don't know what that distance is, but we do know that x is 7 miles nearer to the intersection than the fast car. If that's the case, if that's really the case, what do you think the distance of this guy here is? Okay, it would be whatever x is plus another 7 miles. Okay, just use some numbers. Let's pretend these were numbers, okay? Let's pretend that this were 10. 10. Okay, the slow car has to be 3 because it's 7 miles nearer. So you have to subtract 7 from the 10 to get the 3. Or you could think of it as whatever the distance of the slow car is, add 7 to it to get the 10. Either way. So what I'm going to do is erase those numbers because they're really not appropriate. Undo drawing, right here. And I got another undo drawing that needs to be done. So the first thing that you're going to do is sort of lay out in terms of variables what this diagram looks like. They do tell you that at the same time the cars are 13 miles apart, like they use some sort of Google Maps or something where you can locate the distance between 2 points, and this is supposed to be 13. Now, how do you do this problem? Now, somewhere in your Algebra 1, you must have encountered Pythagorean Theorem, where that's a right angle, Okay, here we have a perfect right angle for these cars and the way they're traveling, and there's a relationship between those sides. And I remember saying, well, that's a squared plus b squared equals c squared. That's the Pythagorean theorem. Now, what does this a, b, and c mean? A and b are the legs. They call this the legs of the 90-degree angle. That's a leg and that's a leg. So a and b would be the x and the x plus 7. It doesn't really matter which one you have for a and b. And c is the long side. They call the long side, the opposite the 90-degree angle. The long side is 13. And so what we're going to do is take, we'll call this a. We'll plug in x for a. We need to square it. Then what we got to do is take x plus 7, and let's make a better looking x, and square that. See, that bundle, this is a bundle now. Again, the theory, the common theme in this course is that whenever you have pluses and minuses, they bundle terms together as one unit. So that one unit needs to be squared, is equal to 13 squared. Okay, so let's bang out what we know 13 squared is. 13 times 13 is 169. You can get that on your calculator. X squared I'm going to put over here because I need to do a little math on this bundle. Now, what does this bundle mean? Now, a lot of people get this wrong, but I'm going to show you what it really means. It means that I got to take this x plus 7 and multiply it by itself. That's what that means. That's what the square means. X plus 7 and square it and multiply by itself. Okay. So let's do the multiplication. You got to do your multiplications before you can do anything else anyway. So this is just a straight FOIL job. First, outer, inner, last. And, you know, at this point, you did this in Algebra 1. I'm going to tell you what the answer to that is. This is 7x plus another 7x is 14x. See, this x squared has nothing to do with this. This is the x times x due to the FOIL job. Plus 49 is equal to 169. Okay, so let's clean this up. Combine your x squares. You got 2x squared plus 14x plus 49 equals 169. So right off the bat there, there's a lot of steps, and a lot of people hate a lot of steps. A lot of students just want to do one, maybe two steps and be done with it, but there's a lot of steps that I showed you here so far. But you got to have faith that each step that you're taking makes sense and you're doing it correctly. Now, I see a problem with this. We're not even done yet, by the way. We're close to done. We still see we got a problem with a square, and then we got to have an equal 0 to solve it. So I'm going to subtract 169 from both sides so that we get an equal 0. Okay, so that gives me 2x squared plus 14x. Ooh, that's an x. Screwed it up. Edit, undo, control Z. Okay, let's make a better looking x. And so what's that? That's minus 120 equals 0. Yay. Now, we got to factor that. Now, those, don't forget, all the steps that I showed you, you do the same way. Pull out. I can see every number is an even number, so I can pull out a 2. That means I have 7x here, minus 60. I don't want to make a mistake. 60 equals 0. And you just go ahead and solve this. Just factor that. Factor this. This is x and x for the x squared, and then we see a minus 60, which means we have a plus and minus. And two numbers that multiply to be 60, add or subtract to be 7. So what would that be? What would that be? We need two numbers that multiply out to be 60, add or subtract to be 7. I'm going with 5 and 12. 5 and 12. Let's put a 12 here and a 5 there. Yep, that would work. 5 and 12. Yep, that would work. Yep. So now what we're going to do is set our factors equal to 0. 2 is a factor. Bring that down. 2 is a factor, but 2 doesn't have a variable on it, so it makes no sense. Let's set x plus 12 equals 0 and x minus 5 equal to 0. Okay, those factors, and this gives me x is negative 12, and this gives me x is 5. Okay, so we're done. We're done doing the analysis. Let's figure out what this means. Negative 12 is mathematically correct, but doesn't work in this problem because when you measure distance, you don't measure negative 12 miles. Okay, your odometer is always going positively. So negative 12 is not appropriate for this problem because you're going a positive distance. There's no such thing as negative distance when you're measuring something, a distance. So I'd forget about the negative 12. This 5 can possibly is the answer. But what does that mean? 5 represents x. See, x is 5. X equals 5. X represents, go to your picture, the slow car. The fast car must be 5 plus 7, which is 12. And that 12 has nothing to do with the negative 12, so don't worry about that. There's no relationship. So make sure you put the 5, after doing all this math, it'd be a shame to get this wrong because you put the numbers in the wrong spot. The fast car didn't go 5 miles, it went 12 miles, and the slow car went 5 miles. Check your answer. Great. Okay, so it's not that intense. Don't make this intense. Just believe in yourself and that we got we went through all the steps necessary to do the problem. All right, let's do another one. Number 17. And this definitely needs a new sheet of paper. Number 17, file, new, and we'll say okay. And a little word about number 17. A word about number 17, and whoever wrote this problem, I inherited this course, by the way. I did not make up this course. I inherited it. And I don't know who made this course up, to tell you the truth. But the person who wrote this this problem probably had a bad day. Just like in a couple of videos I made, I had a bad day when I came up with the wrong answer, and it was a silly mistake. Now the base, here's why they had a bad day. Now the base of a large building is a cube. That doesn't make any sense. A cube is a three-dimensional area. A cube, I'll try to do a cube as best I can on here. This is a cube, and that cube is resting on the ground here. Okay, I think what they meant to say is the base of a large building is of a building that's a cube is a square. That's a square. Okay, the area of each side of the cube, the cube basically means that the length, the width, and the height, all three sides are the same length. The area of each side of the cube is this. So basically, let's take a side. Let's take this front side. Okay, that's that's length and width right here. Length and width, and you've got to know that the area of a rectangle, or a rectangle, is the length times width, and it just so happens that for a square, the length and width are the same, so we'll call that x. X and x, they mean the same. They got the same value. And when you have different letters, you tend to think that you have different values that go in there. But with a square, length and width are the same. So I'm going to call that x and x. And that's going to be x squared for a square. Now they're saying that area is 15,625 equals x squared. Okay, now how do we do this problem? Here's what you're going to do. You're going to set, well, I got to set it equal to 0. Subtract that big number from both sides. X squared minus 15,625. And you know what? If they gave you a problem in this chapter, there's no undefined or can't do the problems. There is an answer here. And so chances are there's a way to do this, and so this is probably a perfect square, a difference of two squares. Chances are it's going to look like this: x and x, plus and minus, that's the pattern. Now we need to come up with a number when multiplied by itself gives you this big number. Well, it's not a fair question, because in order to get that, you need to have some sort of tables of squares. I'll let you, I'm going to cheat a little bit and get my calculator going here. And remember this square root? I'm going to punch in 15625. Okay. Take the square root of that. And what they're saying is that 125 times 125 is equal to 0. What they're saying is that x is, if I set those factors equal to 0, x is negative 125 or 125. Okay. You need a calculator. I'm not sure why in order to do this problem, I'm not sure why they gave you such a big number here, because it's not intuitively obvious that 125 multiplied by 125 is that, but luckily this problem you won't see ever again, only on this type of homework, and so you'll probably have a different number here when you do your homework. The only answer that makes any sense is the positive answer. Same reason. When you measure a distance, when you measure a length, you don't measure negative numbers. So I'm going to take a 125, check your answer, and fantastic. Now you won't see this on a quiz, and you won't see this question on a test, I can assure you. It's only on a homework. And if I had it to do over, I would probably get rid of the question, but I don't have control over that. Okay, so last question, number 18. And I'm going to need to have a nice sheet of paper fresh to do this problem. File, new, and okay, and move this over here. Now, what's this all about? An object is thrown from the top of 160. Okay, here's a building. Here's the building. Okay, and this is the ground, and this is the roof. On top of there, there's a guy, some criminal, who's throwing big stones off that building. So he throws it up in the air, and it's whatever goes up has to come down. Boom. Okay, and the distance from the ground to where he throws the rock is 160 feet. 160 feet. Now, they're telling you after t seconds, the object's height above the ground is given by this expression. Okay, let's just accept it. H is equal to negative 16 t squared plus 144t plus 160. Okay, that's 144t. Now, how many seconds will basically what this says is if I were to plug in t is equal to 1, like you let go of the rock at t is equal to 0. If I plugged in 0, 0 squared is 0, so this whole term is 0, and 144 times 0 is 0. Basically what you're saying, at the time you let go of the rock, the height is 160. That makes sense. If I were to plug in 1, now, I'm not going to do that, but if I were to plug in 1, what happens is this calculation will tell you how high off the ground the rock is at 1 second. If I plugged in 2, I get the distance of how high the rock is above the ground at 2 seconds. What we want to find out is how many seconds does it take for the rock to hit the ground? Which is basically saying when the rock hits the ground, the rock is sitting on the ground 0 feet. And so you're left with this equation, which looks kind of familiar. It's you've got a quadratic, a squared term. Okay. Plus 160. And in order to do that, you have to factor it. Now, these look like big numbers here. Now, to do this problem, we've never done this that often, and okay, it just so happens, let's take a look at this 144 and 160. I think we can divide, certainly we can divide 16 into 160. That goes in 10 times. But if you take your calculator and divide 16 into 144, it goes in 9 times. So we should be able to pull out a 16. But in addition to pulling out a 16, we're going to pull out a negative sign. So what we're going to do, so we haven't done this that often, but you can pull out a negative number. What does that mean? Any number you pull out basically says divide that number 144 by negative 16, divide 160 by negative 16, divide negative 16 by negative 16. You get a positive t squared. Negative 16 into there is minus 9t, and negative 16 divides into 160 a negative 10 times. I know that's right. Multiply through, and you'll get the original expression. See, the problem is we've never really, I think this is the first time we've ever actually factored out a negative number, but that's okay. We factored out the negative number. We should be able to factor the square term, the quadratic part, and I get a plus and minus. I'm going to go with 10 here and 1 here. Negative 16 equals 0. We've got 3 factors. Set the factors equal to 0. Principle of 0. Negative 16 equals 0 makes no sense because there's no variable there. This factor here is t plus 1 equals 0, so that means t is equal to negative 1. And this guy here is t minus 10 equals 0. Let's make a better look at t. So when we add 10, we get t is equal to 10. Don't use this. Don't use that. That's wrong. Okay, remember, we let go of the rock at t is equal to 0. Mathematically, t minus 1 is a second before we let go of the rock. So we still have the rock in our hand. So that doesn't make any sense. It's going to hit the ground 10 seconds later. 10 seconds later. So don't put negative 1. No negative numbers in these problems. Put 10 in there. Check your answer. Great. Okay, so that's the end of section 6.5. It's also the end of chapter 6 that's in the book. And so the next thing that you're going to do, you're going to do this homework. And don't worry about the word problems. If they upset you, just do your best. The next thing that you're going to do, the next unit will involve taking a quiz. That next quiz is on section 6.4 and 6.5. You need to take the quiz, and then you need to take the test. The test is 20 questions on everything in chapter 6. So there's a little bit of 6.1, a little bit of 6.2, 3, 4, and 5. You might get one question that's a word question, a word problem. Okay, so don't worry about it being a majority of the test. It's just going to be straightforward questions. Okay, good luck to you. Bye.